Hi everybody, I'm ready to make the last video for chapter 13. The law of cosines is our topic for today. And if you remember when we studied in 13.5 about the law of sines said that if you had the sine of angle A over side A, it would equal the ratio of the sine of angle B over side B. Or if you had C, then sine of angle C over side C. And the law of sines worked when you had two of one thing and one of the other. So for example, it worked if you had an angle and a side. It worked if you had an angle, a side, and an angle. And it even worked if you had a side, and an angle, although sometimes in the other order. So for those three scenarios, you could use the law of sines. You had to have two of something and one of another. Now, the law of cosines that we're going to do today works for some of the other situations. It works if you have all three sides, which is pretty amazing. You don't even have to have any of the angles at all. If you just have all three sides, it'll work. And it also works if you have two sides and the angle that is in between them. So the law of cosines will work for those two scenarios. So the law of cosines looks like this. There's three versions of the law of cosine. They all look, well, exactly the same, except for which letters are in which spot. So the first one I'll write down is this one, and you're going to say, that looks so familiar to me. Because the first part of it, a squared equals b squared plus c squared, it looks like the Pythagorean theorem. But then it's minus 2bc times the cosine of angle A. Now let me write down the second version and see if you can see the pattern. B squared equals a squared plus c squared minus 2ac cosine of angle B. Okay, I bet you can figure it out. The third version, see if you can figure it out before I even write it down. I'll give you a second to think. It's going to start with c squared. What are the two letters that are going to go here? Well, not c, because we already used c, so it needs to be the other two. So you're going to say a squared plus b squared, and then it's going to go minus 2. And then notice that the two letters that come after the 2 are the same two that were just before the 2. So this is going to be AB and then cosine of angle C. So notice in this, the angle that's at the very end always matches the side that's over on the left by itself. And then the other two sides are in these other spots in the formula, here, 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 here. Okay? So you can use whatever version you want, but you have to have all three of the sides, and then you can solve for the angle. Or if you have two of the sides, you can, and one of the angles, then you can solve for the third side, and then you can keep going from there. So let me show you how it works. Didn't mean to write right there. I've got to change one thing here. I don't want to draw with touch. That's why I was doing that. All right, so I'm going to go straight through the examples that are in the book. I'm going to do 4 examples, 3 of the law of cosines and then 1 of a new area formula. So the first example in the book gives us a picture of the triangle. So it's nice when you have the picture. If you don't have the picture, you're supposed to draw the triangle yourself. Some of you are resisting me on doing that, but you are supposed to draw the triangle yourself. So the first example has a triangle, and all the parts are labeled for us in their right spot, so we don't have to figure out where they go, but you can always make up your own triangle. Just try to make it as realistic as far as the size of the angles goes. So this one says that B is 38 degrees, side C is 16, and side A is 12. If you haven't figured it out by now, the side is always across from the angle with the same letter. All right, so we want to find all the parts of the triangle. So I still do the same little thing that I used to do with the law of sines. I make a little table and I put down what information I have been given in the table. So I say A equals, B equals, C equals, and then A, B, and C as the sides. So in this case, I've been given angle B, 38 degrees. I've been given side C of 16 and side A of 12. So see, we have side, angle, side. We have this scenario up here, side, angle, side. We have the angle in between the two sides. So this is a perfect example for us to do the law of cosines. And I'm going to choose to use this version of the law of cosines right here, because angle B is the one that I've been given. And so I also have the two sides on either side of it, so I can solve for side B by plugging in the three pieces of information on the right side, and it's just going to be one long calculator input, and I'm going to get side B. All right, so my pen keeps dying. You guys aren't surprised. That happens to me all the time. Won't hold a charge. Okay, so side A is 12, so we're going to say 12 squared plus C is going to be 16, so 16 squared, minus 2 times 12 times 16 times the cosine of angle B, which is 38 degrees. And honestly, thank goodness for graphing or scientific calculators, I guess I should say, because you can enter that whole long calculation. Your calculator knows how to find the cosine of the angle. It knows order of operations. It knows how to square things. You can do all of that and only push equals once. And you're going to B squared equals, I didn't do it. Looks like it comes out 97.4 and some other decimals after that. And then the final step, you can leave that on your calculator and you can take the square root of it by doing second square root and then second answer, ANS. It's usually above the negative sign on your calculator down on the bottom. And you can recall that previous answer and your calculator will take the square root of 97.4, or you can retype 97.4 if you want. It's not that long. And you get 9.87 for side B. 9.87. Sorry, I haven't been able to write it down because my pen keeps dying. And I charged it right before I started this video. All right, so it comes out 9.87. So that's our first find, 9.87. Okay, now that we have side B across from angle B, now that we have these two pieces of information, now we can go back to using the law of sines. The law of cosines is pretty long. The law of sines is a little bit shorter, right? It's just a ratio. So now we can find the other angle, either A or C, to find the second angle. So we can use the law of sines. It's oftentimes suggested that you go with what you think is going to be the smaller angle first. And so I'm going to go for A right here. All right, so I'm going to say sine of angle A, I do not know that angle, over side A equals the sine of angle B, that was one of my given angles, over side B, which is 9.87. I'm going to have to use that rounded off value because I don't have any other option. Okay, so I'm going to cross multiply. I'm going to get 9.87 times the sine of angle A equals 12 times the sine of 38 degrees. I'm going to divide by 9.87 on both sides. That's going to give me sine of angle A equals 12 times the sine of 38 degrees divided by 9.87. And I need to ask my calculator now to unsign that. Unsigning means that you want to inverse sign something, right? You want to unsign it. So I'm going to take the inverse sign of both sides. That will undo the sign, and I'll get, I have to type all that into my calculator. And if you're still having trouble not getting the right answers, I would guess it's because you're not closing your parentheses after you take the sign. So like sine of 38 degrees, close the parentheses before you divide. And that turns out to be 48.5 degrees, because this was an angle. So now we know angle A, 48.5 degrees. The last angle, sometimes students get overzealous and they want to do another law of sines calculation, but guess what? You don't have to. Because if all you're missing is an angle, you can just subtract from 180. So you can do 180, take out the 38 that was given, take out the 48.5 that we just figured, and what's left? 93.5 degrees. 93.5 degrees. All done. The values that we found were angle A, angle C, and side B. We used the law of cosines, and then we used the law of sines, and then finally we subtracted from 180. So we used both of the formulas that we've learned. All right, let's do another example where we have all three sides. This one's so interesting to me that it actually works. So here's an example where you're given information. It says triangle ABC has three sides, 8, 18, and 13. So however you want to draw your triangle, doesn't matter to me, but try to realistically put the sides where you think they should be. 8, 18, and 13. So 8, 18, and 13. If I label it that way, the way I've drawn it, I put the longest side on the bottom. You could draw it differently if you wanted. So they're saying that, let's see, this is A. So across from the side that is called side A, I'm going to put angle A. And across from side B, I'm going to put angle B. And across from side C, which is 13, I'm going to put angle C. Okay, so here we go. This time, we literally know none of the angles. All we know is the three sides. We have side A is 8, side B is 18, and side C is 13. So we've got to find all three angles. So we can use whichever one of the law of cosines formulas we want to, but it's recommended that we go for the biggest angle first. So which one's going to be the biggest angle? Well, if you think about it, the biggest side is the 18. So angle B should be the biggest angle. So that would be B squared equals A squared plus C squared minus 2AC cosine of B. And what we don't know is B right here. That's what we're trying to solve for. So if we fill in, it would be 18 squared equals 8 squared plus 13 squared minus 2 times 8 times 13 times the cosine of that angle that we don't know. So unless you're really good at squares, you probably are going to get out your calculator at this point. I didn't know what 18 squared was off the top of my head. Excuse me. So 18 squared is 324. 8 squared is 64. 13 squared is 169. I did know those two. And then minus 2 times 8 times 13. 2 times 8 times 13 is 208. 208 times the cosine of B. Pen is dead once again. I'll give it a few seconds. 208 times the cosine of B. Okay, so how are we going to solve for B? Again, remember, this is what we're trying to solve for right here. So we need to move everything we can away from B. So my suggestion is do whatever simplifying you can before you start moving stuff. These two numbers can be combined, but not the minus 208. It's attached to the cosine of B. It's being multiplied times the cosine of B. So we'll have to deal with that separately. 169 plus 64 is 233 minus 208 cosine of B. It's getting better. Trying to solve for B. So I got to move stuff away. So I'm going to subtract the 233 over to the other side. That'll be a nice step because then it'll be even simpler. We're getting there. Now I'm going to divide by negative 208. I'm going to divide by negative 208. Now maybe that seems weird to you that we're going to get a negative 91 over 208. Remember, the negative can go either on the top or the bottom. It doesn't matter. But now to finish this problem, I need to uncosine it. So I'm going to inverse cosine. Cosine to the negative 1 means undo the cosine function. And when I do that, it's going to tell me how big angle B is. It's going to tell me what angle has a cosine value of negative 91 over 208. Thank goodness that's in our calculator's memory. Inverse cosine of negative 91 divided by 208. My calculator's in degrees, so it tells me that the angle is 115.9 degrees. Let's see. Yep, let's leave it 115.9. We'll be nice and accurate there. Okay, so 115.9. So we've solved for one of the three angles. We didn't know any of them when we started this problem. But we did all this complicated algebra, trigonometric, and we did it, and we got 115.9. Okay, now we have to find another angle. So it's really up to us whether we want to find A or we want to find C. But we only have to find one of them because then we can just subtract from 180 to get the final last angle. So I'm going to use the law of sines to finish this problem because now I have an angle and a side across from each other. So I'm going to go for A. So I'm going to say sine of A, I'm going up here next to the triangle. Sine of A, I don't know what angle A is, over 8 equals sine of 115.9 over 18. And I'm going to cross multiply. You guys know how to do that. I'm going to inverse sine it, and I'm just going to go ahead and tell you guys what the answer comes out to be. It comes out to be 23.6 degrees. Okay, using the law of sines. So I use the law of cosines once, and then I use the law of sines to finish the problem. That's how most of these go. You don't have to use the law of cosines twice. You can just use it once and then finish with the law of sines. And then finally, the final angle, don't beat yourself up over this one, just subtract from 180. Take 180, subtract out the 115.9, subtract out the 23.6, and what's left is 40.5. Final answer, 40.5. So what we found was all three of the angles. We started with the three sides, and we ended up finding all three of the angles. And think about it. The biggest angle is across from the biggest side. The smallest angle is across from the smallest side. Okay. I was going to do a word problem for you guys, but I think you get it. The word problems are almost easier because then you see the picture and it makes sense to you. So the last thing I'm going to do is I'm going to teach you another formula for area of a triangle. So back to geometry, area of a triangle, 1/2 base times height. Last lesson, 13-5, I taught you about a formula. It was 1/2 AB times the sine of angle C, and then there were a couple of other versions of that area formula. Well, today we have one more formula for area, and this one is called Heron's formula. It's the name of, I believe it was the Greek mathematician who invented this formula, or discovered this pattern, we should say. And it's a really interesting formula. It says to find the area of a triangle, you actually don't need to know the base and the height. You don't have to know two sides and the angle in between them. You can do it if you just have the three sides of the triangle, which is really interesting. And here's what the formula looks like. It says to find the area, you take the square root of this number called S, which I'll tell you how to find that in just a minute, and you multiply it times that same number minus side A, times that same number minus side B, times that same number minus side C. It's called Heron's formula for area of a triangle. So where do you get this number S? S, it turns out, is exactly 1/2 of the sum of the three sides. How weird is that? Take the three sides, add them up, divide it in half. Take that number, multiply it times that number minus the first side, that number minus the second side, and that number minus the third side. And when you multiply those four numbers together and take the square root of it, you'll get the area of the triangle without ever knowing how high it was. Now, the reason that's cool is if you think about it for like mapping. If you have 3 towns or 3 locations, you know, let's say someone has a tree here, and over here there's this lake, and over here there's this big rock, okay? And they want to know how much area is between those. They don't have to know the angles, they don't have to anything. They just have to measure how far it is between each of these, and they can figure out how much space is inside this triangle. They don't have to find the height of the triangle. I mean, imagine if they had to figure out, okay, what's the perpendicular line that goes there and find the height of that triangle. So you just have to know the 3 sides of the triangle. So let's do an example of that, and then I'll stop. So let's say we had this triangle, And let's say that it was 22 on this side, and it was 40 on this side, and it was 50 on this side. And I don't even really care which one's A, which one's B, and which one's C, because they're all used in exactly the same way for this formula. So the first thing I have to do is I figure out this number S. So I take half of the sum of the three angles, or sorry, three sides. Well, I should be able to do that in my head, huh? I don't know why I'm typing it in. 90 plus 22 divided by 2. I got 56 for S. So to find the area of the triangle, it's the square root of 56, that's our S value, times 56 minus 22, times 56 minus 50, times 56 minus 40. And guess what? You're never going to get anything that's going to give you a negative underneath there, because that would be impossible, right? You can't have a triangle that has a negative square root, has an area that has an I in it. That wouldn't make any sense. So if you do the math on your calculator, you can let your calculator do the subtraction if you want, or you can do the subtraction first and then multiply the numbers together. Turns out to be approximately 428 square miles or square inches or whatever the unit was that you were working with. And that's it. That's called Heron's formula for area. All right, so your assignment for this chapter, homework, home learning opportunity, whatever you want to call it, it's page 810 to 812, but there's only 8 problems. I want you to do numbers 15 to 19, all of them, that's 5, and then I want you to do 3 word problems, 50, 51, and 53. And please, feel free to check your answers in the back of the book as you go and see how you're doing, but make sure you show your work, show me how you set up the law of cosines, how you set up the law of sines, draw a picture. Please show your work so that I know that you're setting these up right and I can help you. All right, thank you.